everyone enjoys a good TV episode of CSI or Law & Order on a lazy afternoon. The storyline often begins the same. A body washes up on shore, and one of the first pieces of information detectives need to figure out in order to solve the crime is where the body came from.
Sex. For most living things, is at the top of their bucket list. But it's a time and energy-consuming enterprise. It can even be dangerous. Take the oyster, maybe the animal most prolific at making sex cells.
There is a giant plate of steamed mussels put in front of you at the dinner table. Your lips start tingling with anticipation as you engulf the contents of the plate. As you sit back, satisfied with the delicious meal, your lips start tingling again, but this time your entire face goes numb. This could be due to paralytic shellfish poisoning, and you should absolutely go for help.
For my research, I'm investigating the location of mortality of turtle subjects. Each year, hundreds of turtles wash up deceased on local beaches. Now, back in the 90s, there was an average of about 85 strandings a year. But this number has increased to the 200 to 400 strandings that we see today.
Every summer, an oyster transforms most of its body into either eggs or sperm. What if we could stop the oysters from having sex, allowing them to be fat year-round? Well, then you'd always have a fat oyster, an ideal seafood product. These ever-fat sterile oysters and the technology to produce them was created decades ago.
Paralytic shellfish poisoning is caused by a toxin produced by microscopic algae. The mussel eats the toxic algae, and then when we eat the mussel, we are exposed to the toxin. Massive blooms of this toxic algae are becoming common throughout the world due to an increase in the algae's nutrient food source.
Upon death, turtle carcasses sink until internal gases from decomposition causes the body to bloat and float to the surface. At this point, the body's movements are largely dependent on physical processes, such as currents and winds. For my research, I'm using computer simulations to model these movements.
Sterile oysters are not always sterile. Last year, we found some supposedly sterile oysters filled with eggs. What's more, these oysters came from a commercial farm that was experiencing an unusually high rate of oyster mortality. Why are they behaving this way? Well, just like walking and talking, sex is a behavior. And what controls your behaviors? Is it your genes? Is it the environment? Someone wiser than me put it this way: genes load the gun and the environment pulls the trigger.
Americans eat an excessive amount of corn-based products. Corn has a high number of carbon-13 to carbon-12 atoms compared to other plant sources. This means that I will have more carbon-13 than somebody from another country. I'm using this same concept to identify the nutrient sources fueling the toxic algal bloom.
Once these potential mortality hotspots have been identified, I will look at activity in the area that may be contributing to turtle mortality, such as interactions with fishing gear or cold water temperatures.
We've now set the trap to catch the culprit and his murder weapon. Next spring, we'll carefully check our trap every month to assess oyster survival, condition, and of course, how good these oysters are at sex.
From this research, the number of nitrogen-15 in the algae can be used to identify where to reduce nutrient discharge, to hopefully stop the algal bloom from occurring and reduce the number of cases of paralytic shellfish poisoning.